Hello. The first two videos of this series I showed you how to set up a Gotek Floppy Emulator for the Amiga and added some hardware modifications. In this video I will show you how I made a custom Amiga 500 mount that it simulates a floppy disk. Here you can see how it operates. The thumb drive goes into the eject buttonhole, which also ejects the disk. I fitted an OLED screen and navigation buttons into the disk itself. If you only wanted to see the end product, you can stop this video shortly. The rest of this video is how I designed this end product. Anyone not interested in such things may find the rest of this video boring. Anyway, I got the idea to do this mount from Thingiverse, a site for freely exchanging 3D printer object files. Let's check out that first, since it's where I started. Okay, so here on Thingiverse we have the original object by Ashes Man. Props to him for coming up with this idea in the first place. There are a couple of improvements or changes I'm going to make to this design. This is for the 1200. He says it can be adapted for the 500. I basically started from scratch. The only object I downloaded was the disk object, and that was just to look at it, just to see sort of what he did, but I knew I was going to change it. And what I wound up doing is recreating the whole thing from scratch. Okay, so here we have the original object imported into my 3D program, and a couple of things about the design that I noticed were this part of the disk, the the disk door that slides open and closed, and this arrow here. Everything basically from this point out to this point are never visible from the outside because the disk only slides out 2/3 of the way or whatever. So I just didn't see the point of having that in my design. Another thing is he created this in order to simulate the larger edges. The edges of the disk here are thicker on an original disk than this center part here where you put the label. It's a slightly recessed or stepped down area. His solution was to create a channel that goes over and around. His design here doesn't have any openings on the top. He assumes that you're going to print this out and then he has it very, very thin in the areas where you need to cut it out. You can almost punch it out, I guess. But I mean, you do that and you're going to have to finish it off somehow. So my design, I treat all of this differently. I'm not saying that he's wrong in what he's doing. I just have a different way of doing things. I plan to have a base object, and then this is actually going to be a separate object that I print that I'll simply glue to the top of the other one to create that stepping effect. Because indeed, because of the detail that's required underneath, you have to print this upside down in order to get the details right. Yeah, because we're going to have some steps here, and obviously this is all going to be messed up if you don't print it correctly. So this copies his original design in the fact that he has like a channel cut into his object for wiring the buttons, and I guess you would assume that you'd want to glue this stuff in, otherwise I don't see how it would stay. I think in this particular case I was checking out the ability to create this second piece that's on top. So here's my final product. Here's my top piece, and the top piece has two separate pieces that you print, because obviously when you print something like this you can print it upside down, and these will print, except for a fact they're not going to come out very well, especially when it's only like a millimeter thick. It's going to come out kind of inaccurate. You're going to get some oozing and whatnot, and it's just not going to look right. So I print these as two separate objects on the printer face down so that they come out really well. And here's the big change I did. The buttons, I created a rocker switch for scrolling up and down, and the eject button is right next to it. And then the display is kind of in the same place. So let me just show you how this, plus I have this cover, and this cover worked out extremely well, better than I could have expected. I designed it to perhaps glue in, perhaps screw in, but then I discovered that there's no way I would get usable screws of the right size that would go flush, because this is only a few millimeters thick. So I created an angle on this object and on the main object so that this thing would actually slide in by itself and just sort of lock itself in. And it really worked very well. So this is the way you would print these objects. This one like this and this one like this. And here are some, I modeled some switches, some momentary switches. These are available on Amazon or wherever. They're the smallest, pretty much the smallest switches you can get. And they're somewhat SMD type. I mean, the contacts on these aren't these posts. They're like right here, and yeah, they're basically SMD type. They're very tiny. So I plan to use tiny wires anyway. So, and I'm not going to put any strain on them. So these cylindrical things on top are posts that these switches come with, assumedly to hold them in place in a circuit board or whatever to go through. I wind up chopping these off so that this slides over nicely. Originally I had created this with holes for those and a hole for this, and I raised this up, this middle post up, and created a hole for it. But I found that it was very difficult to get this thing on. You know, it's just not wide enough to have much flexibility, and it became unnecessary. When this thing slid in, it fits snugly because of the surface area here and down here, and there's quite a bit of surface tension to hold this in. And obviously the further or tighter you push this into the chassis, the tighter it will be. It creates its own tightness, plus in addition to having this angle on here. I created this rocker switch assembly. It's just a simple piece of plastic that fits over this post. So the eject switch also just has a mechanical linkage to the outside, you know, to press on. You know, that sticks out farther than the switch would itself. It fits, these switches all fit very snugly into this base, and with the lid on, it doesn't move anywhere. So you actually don't have to glue any of this stuff in here, which was my intention. One thing that I will point out is that these are stepped down, these areas are stepped down for the wires to pass through, because these higher areas are flush with this piece. So the wires get attached to these, and they exit out the back here and come through here and join up with the wires from the OLED screen. Now the OLED screen, this is just a matter of getting the dimensions really close, and also that also precludes having to glue it in. There's a ribbon cable. I'm kind of frustrated at the design of the OLED screen, because I thought you could just close this area off or just create a hole just big enough for the actual glass of the screen. But on this side of the OLED screen, there's a ribbon cable that seems to be flush with the front of the glass, and it comes off the screen, and so you have to account for it. You can't put any material here because the ribbon cable needs to come out and, you know, get it kind of loops around and attaches to the circuit board. The ribbon cable itself doesn't go the full width of the unit, so I was able to make a little piece of plastic here to keep the OLED screen from just simply falling or being pushed into up above the object, if I can speak right. And again, this design seems to have worked pretty well. I'm satisfied with the result. I didn't have huge expectations for it, but it exceeded my non-huge expectations as far as that goes. However, you know, some of the materials I'm working with or some of the techniques are, you know, basic. And I think the part that I'm most unsatisfied with, I believe, is I made a label that fits over this area. And, you know, I just have sticker paper and an inkjet printer to create the labels. The label extends around this hole to, yeah, and I also printed it in black so that the OLED screen would sort of blend in a little more. And it comes across this area, you know, so that you don't see this edge here, this corner. Okay, so once having created the disk object, then comes the time to create a holder for it, for the Amiga 500. And obviously it starts with creating something dimensionally that will fit into the Amiga 500 and have the disk line up with the original disk hole. One luxury that we have here is that the disk slot in the side of the Amiga 500 is way larger, about twice as large maybe, as a normal disk. So I need to take advantage of that. I need all the thickness that I can of this. So this is thicker than a floppy disk to give me room to put stuff in. So we create a mount that is very basic. It didn't have any of this detail. I was obviously just creating something that I knew would fit into the 500 and that I could continue to design around it so that I could put it into the Amiga 500 and test fit it and make sure the disk comes in and out and make some adjustments on the height. And obviously the way this is printed, you wouldn't print the standoffs together with it. You wouldn't have it part of this object. So standoffs are a separate object, and simply just glue them. There's 3 posts in an Amiga 500, 1 here and 2 back here, vertical posts, and then the 4th corner is held on a lateral screw and screw mount. So getting all those holes to line up and be perfect was key. Once I had that object done, I created mounts. That's annoying. I created mounts for the Gotek PCB so that it would fit in here, and I found out that the best way to do that was to turn the Gotek upside down so that the larger through-hole components were sticking down into the empty space below for clearance purposes. I was thinking about what I would do with the eject hole in the Amiga 500 case. The previous guy had simply created a place for you to plug the USB drive into. That seemed like a really good idea. I couldn't really come up with any other place to plug the USB drive other than maybe the front of this, but then there's just not enough room. It's not thick enough. So I pretty much resigned myself to the fact I wanted the eject button to be a functional eject button. I really didn't see how that other person's design was you were going to actually grab the disc and pull it out. I would assume that I guess the disc sticks out enough so that you can grab it with your hands. But you know, when an Amiga disc is inside the Amiga, it doesn't stick out at all. And I thought, well, it would be really good if I could make some sort of eject mechanism with a simple lever. But I also what am I going to do? I'm going to also have to make it the USB thumb drive socket. So I did both. The problem with that is obviously when you're plugging a thumb drive in, it's going to eject the disk, obviously. But I was thinking to myself, when do you want to plug a thumb drive in? And would it be a big deal if when you plugged the thumb drive in, it would eject the disk? And I thought to myself, well, not really. It's not a big deal. And then pulling the thumb drive out, that's not going to do anything because just like the Amiga, it's not a two-way lever. It's just a push lever. You can't pull it out. You simply reverse the mechanics by pushing the disk in. So that is the same design I've come up with. So this assembly right here with the exception of this piece right here. I'll explain that in a minute. But this assembly right here is the ejection system. And obviously you can see, well, let me just bring this object back up. So I had to create a cutout to put I simply desoldered the USB socket out of the Gotek and mounted it in a piece of plastic here. And then that plastic is glued to a lever that pushes on a pivoting lever and simply ejects the system. I can actually demonstrate this somewhat because I have the, when I'm designing something like this, I'll put the origin of the object right in the center of the hole so that I kind of know how it's working. So it gets pushed and it simply ejects. So you push the lever this way, this gets pushed that way and ejects the disc. And this is made fairly thick, as thick as I could go on this piece, because it's going to take a lot of strain, especially in this area. So, and I also created somewhat of a bolster in the back to have even more strength. And then I have some stops that I printed separately, a stop here and a stop here. These are the separate objects here, and those get printed separately. So obviously you create an object to fit the thumb drive socket, the USB socket into. This is the top spun around, you know, and there's channels cut into it. And this was actually fairly complicated because the USB socket in the Gotek, there's quite a few different surfaces, planes of surface on the thing. So I finally got that done. And then I simply created a nice surface area for it to be glued onto on the lever. So this is quite a bit of surface area to have glue applied to. Plus this area needs to be super thick. From this point over to this point, there could be a lot of strain, sideways strain or whatever, from plugging a thumb drive in. You want this to be as thick as possible, but then when it comes to actually getting into the portion where there's only one force being applied, a pushing and a pulling, you don't need it to be as thick. And so I just simply knew that I was going to cut a channel so that this thing would have an easy way of me just locking it in by simply gluing this piece and this piece to the base, and then creating a stop here for pulling out and a stop here for pushing in, and that's basically it. And I'll explain that top piece right now. So obviously on additive manufacturing you cannot print very well over an open space, so I simply just chopped this area out of the design and created a piece that you can glue onto the front. So I just kind of wanted to reinforce this area. I of course reinforced it through the back. This creates a more stable object for printing anyway, to hold things down, to create more surface area with the print platform. But I also wanted to make it have more strength, especially around this eject button. So let's just, oh, then of course we have a top piece. And the top piece, I mean, this for servicing purposes or modification or future whatever, or even to just get the Gotek motherboard out, because it's screwed down and its screws are below this. To create a top piece that is removable was absolutely crucial. So we have screw holes, you know, and I don't know if it's M3 maybe, or number 4 screws or something like that. It depends on it. Basically I design things around the hardware that I have, and usually 3mm holes. I usually have hardware for that. So let's just demonstrate how this works. Let's line it up. And of course, like the other design, I do have a step here to stop the disk from coming out any farther, and its mate in the frame is here. And I didn't bother with the any detail around here because it's not visible at any time when using it. Let's just line this up here. You can see the limit about right there. I think we need to come down or up, as it were. Yeah, that's good enough. Okay. So here we have the disk ejected, and we will put it in here. We just have to stop it up against, roughly up against this lever here. Something like that. Yeah, right, there it is. Okay, so pressing on the USB port, this actually doesn't come out of the case, so it actually requires a USB thumb drive in order to eject. But the unit itself is non-functional without a USB thumb drive anyway. So, and the only other design issue is the type of USB thumb drive that you're going to be using. You would have to use a slim USB thumb drive, and I'll show you the one. I got a Samsung one that I bought a while ago that was nice and slim. Obviously thumb drives come in every shape and form, so just simply getting one that has a narrow design that will fit through the Amiga's eject button hole is all that's required. So pushing on this with a thumb drive in it will bring this lever back. It will pivot this lever here, and I actually have a limit. Let me just take this top off for a second. This thing has a limiter. Yeah, the limiter in this, basically this piece of plastic right here acts as a limiter as far as limiting the rotation of this. So let's just see how far this goes. Right about there. And that corresponds to how far this lever will go before it hits its stop. So here we have the drive, and we will see how far it gets pushed out when the lever is activated. And that is how far the disk comes out. It comes out probably a little less than a normal disk would, but you can certainly grab it at this point and pull it out the rest of the way until it hits the stop. And then you can easily read the display from a normal seating position and use the buttons to go up and down and eject. So that's basically all I have to show you on this. Okay, I just thought I'd show you the finished product before it goes into the Amiga. I printed most of it in gray, and then I had another project, so I printed I had black in the printer already, so I printed an unimportant, non-visible part in black, but I suppose you could do the whole thing in black. I printed the floppy in gray. Good neutral color for something that you're going to paint, and obviously what I did is I painted it blue, and then put a black label on it to sort of blend in with the display. But I did spray it with clear spray, glossy, but I mean, we're just dealing with regular sticker paper, so using like some sort of plastic-based sticker paper would work better. Anyway, and you can see that I printed the label in the orientation that it normally a disc would have. That's another way I differed from the original design. He just printed it in the way you would read it, but I thought it would look more disc-like if you put it, you know, the way a disc would be oriented. And I just called it the Amiga Gotek 500, and then there's my website underneath it. And here are the arrows I was talking about. Here's the eject arrow, and the up and the down arrows. Hopefully that's in focus fairly. And you can see that this whole area, it doesn't get exposed. You can't see it, so there's no point in trying to do any sort of tricky design there. It's a waste of time. Nobody will ever see it except if they take it apart. Another thing I want to review is another mod you can do and I've shown it on my previous video, is the piezo speaker. And I just, you know, I don't know if this is the best place for it, but it was a convenient place that allows me to, I mean, it is connected to the Gotek, which remains in this chassis, so just to have this secured somewhere on the chassis was convenient for my purposes. Also, you'll see that these are kind of bare wires rather than some sort of ribbon cable. And I might have to do some tying up of the wires or management, cable management of some kind, to ensure that they don't get all tangled up. Probably with this lever would be the only thing, I think. So over time we'll see what goes on with that. But the reason why I didn't use a ribbon cable for this, as shown in the previous, and you would think it would be obvious to do that, is that the ribbon cable has ribbon cables like for drives, like the ribbon cable on the Amiga floppy drive, that has solid conductor wire. And this is going to be flexing all the time when you eject and insert, and you really want stranded wire inside these wires. And I don't know the availability of stranded wire ribbon cable, but I know I have individual stranded wires. And if I had to, I could sort of turn this into a ribbon cable by creating some sort of connection, like, I mean, as simple as a zip tie. Yeah, perhaps a zip tie right here would be the best idea. At any rate, and you can see that, let me just turn this around. You can see I have this slim thumb drive in here, and it works perfectly for fitting into that hole in the Amiga case. And you can see all my other connections. You know, I desoldered, as I said before, I desoldered the USB connector, the USB socket, yeah, I guess you could say, from here, and made a case, a surrounding holster for it, or whatever you call it. And I put it in here, and then I've obviously simply extended the contacts. And this doesn't create much motion. It's only, you know, a fraction of an inch movement, so we don't have to worry too much about strain relief or anything here, just to make sure these wires are clearing. And I can see the underside of the disc. I left this loose so I could eject it. So here is the edge where we have our rocker switches, rocker switch and eject button, and you can see that this is still the piece of plastic that I created that has holes for the extrusion by the switch, little switch posts that are on those switches, and the post that this rocker switch is mounted on. I sliced all that stuff, ground all that stuff down, because as it turns out everything stays in there pretty well just as is, and it's very difficult to slide this in over those posts and make it secure. And this panel here is not secured by anything. It's just secured by friction, and it's actually going to be a little difficult to remove, which is what you want. There we go, popped out. So here we see the OLED screen and those micro switches again that you can get. I bought a selection of micro switches on Amazon, a variety, and I just made sure that it included the very small switches plus some larger ones, because maybe I would use the larger ones, but as it turns out the smallest ones that they had were ideal. So here's that piece of plastic that pushes up against there, and the rocker switch. I don't want to do this too much, but you can see that with my design everything's kind of held in place without any glue. And so to minimize the amount of wiring, I took the ground and looped the ground around. I only need one ground. It's a common ground between the OLED screen and all the switches and everything else. So I have a ground coming from the OLED screen, and I have grounds that are looped from these switches, and they connect right here with a solder joint, and then they proceed along with this last black cable wire here, and just simply go up and attach to a ground point. And that's it. So this thing just slides right in here, and because of the beveled edges, it's actually really secure. and tight. It's absolutely crucial to get the dimensions of this relative to the outside case good enough, close enough, so that it's nice and tight. And basically I found that making them very, very close in dimensions. Normally I undersize panels or sections that fit into others because of the ooze factor that 3D printers have, or the slightly overscaling that most 3D printers have. So in this case, having that tight is to an advantage. So I believe this is very close to the dimensions of the part that it fits into. So I think that's all I wanted to show you. Oh, the switches, the switches that the Gotek came with, I needed to make connections. I could have left the switches there and made the connections, but I figured I would desolder them, but it wasn't necessary. I could have left them there and just soldered onto their existing posts. However, I believe I was worried about clearances, but I think they probably would have fit because they stick down this way. You know, and why not reuse the switches if you can? So, you know, so I just take the signal of the switches from here, and the grounds are again a common with everything, with the USB. Well, the USB is wired separately, but with the OLED and the switches, all the switches, it's all one common ground. So I'm going to put this in the Amiga and we're going to show how it works. Oh, one more thing I should mention. I don't know if you can see it. Let's make sure we can get a good focus here. But there, you see there's a piece of gray plastic I glued here. This is one of those things where you make an adjustment when you're actually fitting your you know, custom designed object. I want this drive, this floppy disk to go in there and be snug. Not too snug that it would be hard to eject it, but snug enough to keep it in place so that gravity doesn't take over. You can see it's loose here as a normal disk would be, but when a disk is in the drive, it's held in place, and so I needed to create something like that. So I just simply got an extra piece of thin plastic. I have some scraps from bad prints and all that, but that I glued here, and with trial and error I sanded it down so that it would be just right, so that it would be just a little bit snug against this. And this right here is the raw plastic of that piece that is creating the extra thickness of this part. This is all a separate piece. This part here and all of this part here and this part here are a separate piece, as well as the two pieces on the end here, to create that extra step that a drive would have. So, but this is raw plastic, and that's what you want. You want raw plastic against raw plastic. You don't want to have any paint on there, because paint, obviously, it rubs off. It does some interesting things that you don't want it to do. So raw plastic against raw plastic, and a nice wide surface of, you know, I think it was at least 15 millimeters or something, so that it can grab and hold it in there until it's ready to be ejected. Okay, so here it is installed in the Amiga, and now these posts, I guess I could make a note of these posts for you. These posts, which were printed after, you know, not at the same time, separately. They were different objects, and they were glued to this chassis. You know, obviously the way you want to do this is to screw the post into the base of the Amiga, and then take the drive and place it on there and glue them one at a time, actually. So I put all three posts in, then I applied glue to one post, put the Amiga drive in where it should, lined it up here, that helped to line it up, and made sure that my, you know, that I was squared up within the case. And then I repeated the process with the other two hole posts, which are under here and under here. I went ahead and took my own advice and put a zip tie on here. It seems the placement of the zip tie probably pretty crucial. There's some leeway in the case. The only thing that might cause a problem is this cover, but I think we're good. We clear that. So that EMI shield, whatever you call it. So if we push the thumb drive, we see we have an ejection, and obviously there's nothing that holds it in this way. I could design another friction-based stop here so that it stays solid, but that, I mean, I don't it's not going to help, I don't believe, with selecting the buttons. Let's see, so right there. So here we have the buttons. I sort of envision a person holding on to the disc with two fingers and then going up and down like that. But anyway, let's turn the Amiga on and see how well it works. Okay, so here we have it mounted in the case. We're just going to test it out before we put the case back together. Looks like we're good. Let's just try. Yeah, the up button works, the down button works, and the insert/eject button works. Great. Let's put the rest of the case together. Okay, so I found that there was a little bit of a folly trying to make the fake floppy disk as thick as possible. I did have to make adjustments. Well, with this sort of project, it's very typical that that would be the case anyway. But I did need to make adjustments to the thickness, and simply that panel that is underneath. Let's see if I can eject it and show you. The panel that is underneath, that you slide in to hold all the wires in and whatnot, that panel, when slid in on my 3D program, it obviously fit, but you know, when you print something out, it comes out usually thicker than what you intended. So that's what happened. So I just took that panel off, and trial and error, sand. You know, that's the kind of project this type of project just entails adjustments, and mostly any adjustments you need to make when you're 3D printing is to decrease the size. It's better to have something too big that you can bring down the thickness of or the size of, rather than something that's not big enough that you have to either reprint or glue something on top of it to make it thicker. This Amiga 500 case is actually a little bit busted. I fixed it, and then a friendly neighborhood cat, well, actually household cat, decided to run through the area where the keys are, where there's a space, and rebroke it. Anyway, so we have this in here. Let's focus right on my finger here on the thumb drive. Okay. All right, so we can see that this is acceptable. Another way to make an adjustment on this is right here where we have that one lateral screw. This one lateral screw down here. You know, it's not bottomed out in its mount at all. it's raised up just a slight bit to make it fit properly. This ground strap, I'm hoping it's for EMI purposes because the drive is plastic and there's no reason to secure it down to it. And the screw here it's just a piece of metal. It's a metal screw into a plastic hole, so I can only get it so tight. But anyway, so that's that. Let's just do a final demonstration here. Make sure we're good. Yeah. Let's have this ejected. God, these things are tight. I'm hoping that I have enough reinforcement in there so that the receiving end of this thumb drive is strong enough to take it. I did do as much bolstering as I thought I could given the amount of space. So turn the computer on. We got that clicking noise. Then we're going to go ahead and put the drive in there. I'm pretty satisfied with the result. This will probably be the picture that I use. Let me take a picture actually. Yeah. Okay. Anyway, that's how I did it. I hope this is useful to you.